Welcome to Premise Podcast. This is your host, Angelo Sophocleus. In this episode, I host Dr. Peter Vickers, an associate professor in philosophy at the University of Durham. We analyze the role of scientific theories today after defining the terms science and theory. We discuss the role of consistency in science and how quantum theory has changed the way we do science. Lastly, we share some thoughts on the relation between science and philosophy and talk about whether any of the two disciplines prevails over the other. Welcome everyone to this episode of Premise Podcast. Today with me I have Dr. Peter Vickers from Durham University. Dr. Vickers received his PhD from the University of Leeds in History and Philosophy of Science, where he developed a new methodology for analyzing debates about inconsistencies in science, which he called theory eliminativism. And this was developed into a book titled Understanding Inconsistent Science by Oxford University Press. Dr. Vickers, welcome to Premise Podcast.
Hi, thanks for having me.
My pleasure. So your expertise in philosophy is on the history of philosophy and philosophy of science. And in general, in science and in the philosophy of science, we talk about scientific theories. But my first question is, what does it mean for something to be scientific, and what does it mean for something to be a theory?
Yeah, there are two big questions, I guess, but science is really defined by its practices, I think. Some people try to define science in terms of a method, but most philosophers of science agree now that there is no one definition of the scientific method, but rather there are many methods. If you agree with that, then you would think that you can't define science through its scientific method. Nevertheless, you might think you don't have to define science perhaps, but perhaps what science is simply a cluster of different activities that happen mainly within universities and so on. Even without defining something, we often have a very good idea what it is. And this is sort of a classic definition of art, or an answer to the question, what is art? Instead of giving a definition in terms of necessary and sufficient conditions, well, we could all agree that if we go into the museum, all that stuff is art. And if we come out of the museum, all that stuff, the buses and cars going past, that's not art. And then, of course, there are tricky intermediate cases, and that's the case with art, and it's the case with science. But there are intermediate cases for anything, even a chair, where when is something a chair and when isn't it? Well, is a quite broken chair still a chair? There's always intermediate cases, even for the simplest concepts, and science is no exception. So I think the short answer to what is science is simply it's all those things that go on in physics, chemistry, biology departments, and psychology departments, and social science as well. Although once you get into certain areas of social science, it starts to become a little bit more fuzzy, whether it's science in the same way that physics is science. But it's the same with physics, where once you get into the most abstract mathematical theoretical physics, some people say, is that really still science? So there were always these grey areas, but that's my the short answer, I think. Mm-hmm. And the scientific theory is best described as a collection of propositions, claims about the world, and in particular claims about aspects of the world which are hard to access. So things that are usually entities or processes which are unobservable, like the center of the earth, or the deep history of our earth and the evolution of different species and so on, or so it can be something that's far in the past. It could be a process which takes a very long time, so we can't observe it except what's happening right now. It could be something that's a long way away, and we have all different scientific theories about that. Of course, the classic case of science concerns what is very small, like atoms and molecules, the elements, and so on. So I think science is actually no different from other areas of human activity, except for its target. We look for explanations of all sorts of things in our everyday life. We want to explain why somebody didn't turn up to a meeting, or we want to explain perhaps why somebody fell ill or something. Well, similarly, science is about trying to provide explanations or descriptions of things, but the target is different. The target is less accessible. So, I think scientific theories are sort of initially propositions which make claims about these inaccessible or unobservable elements of the universe. But in some cases, we become so sure that the proposition is true, or at least approximately true, that people start to call it a fact instead of a theory.
So would you accept that there is a distinction that can be made between hard and soft sciences, or is this based on a loose understanding of sciences? For example, physics being a hard science which provides us with facts, and psychology being a soft science which is less strong as a discipline.
Yeah, I wouldn't do it in terms of disciplines. I think you could have hard and soft science, but I'd do it in terms of, if you like, to what degree, the degree of evidence that we have. So, some sciences are, well, either more speculative, and so that's one sense of softer, I suppose, a sort of a scientific field or subdiscipline where everything is a bit more speculative than science normally is. That might be one way to define it. And another one would be where the target system is extremely complicated. So there are no definitive claims can be made, but you can perhaps generate models or rules of thumb or something like that. So that might be called softer again, that kind of science, because you're not looking at definite laws of nature or definite properties of entities, but rather you're trying to build loose models of how things sort of might look in a highly idealized sense, but they're not actually models that are realistic. So that could be another sense of softer, but I feel like I wouldn't do it along disciplines, because I think that there are examples of hard and soft within physics and within psychology, perhaps.
Mm-hmm. And given the current philosophical and scientific understanding of a theory, do you think there is trouble with the current understanding of theory in science and philosophy?
Sometimes, so there's definite cases where people will talk past each other because they have different conceptions of what a theory is. I mean, it's not the case that there is one agreed upon definition of a theory which all scientists are trained with, and that is specific enough that they're not going to end up with different concepts. I think the scientist concept of a theory is a result of the way they've been trained. And that's happened over many, many years. And one scientist can be trained in a very different way to another scientist, depending on the field they're in, or whether they're more of an experimental scientist or more of a theoretical scientist. So I think, when people meet and they start talking about what the theory is or what the theory says, then it is quite possible for them to be talking past each other, because they're actually employing slightly different concepts, even though they're using the same word or the same term, the theory. And their concepts probably overlap enough that in many cases they communicate perfectly well. But in some cases, it may be the case that they, that it's where their concepts don't overlap that is the subject of the conversation, and then it might look like they disagree about something, or that they might struggle to understand what the other person is really saying, or something like that.
Although there might be many different understandings of the term theory, consistency seems to be a common element in all of the understandings of the term theory. Do you think that's true? And do you think inconsistency might be a problem for science? Is it necessary for a theory to be consistent?
I don't think so. I mean, there are cases in the past where we've had a collection of equations and propositions that scientists have been using and referring to as a theory, and then later they realized that that set was inconsistent. So if a theory can't be inconsistent by definition, then that whole period of time before they realized it was inconsistent, and when they were referring to it as a theory, they were wrong. It wasn't a theory. They just didn't know that. I don't find that a useful way to think. I'd rather say that they did have a theory, and they just didn't realize that it was inconsistent. So yeah, I mean, one of the cases I discuss in my book is classical electrodynamics. So that seems to be a case where the most common formulation of the theory the most common formulation of classical electrodynamics that you find in the textbooks consists of a set of inconsistent equations, or propositions, if you like. And this is what Matthias Frisch put forward in his book in 2005, Inconsistency, Asymmetry and Non-Locality. So that was sort of where my studies started, really, because that came out when I was just starting my PhD. So in that case, it seemed, I think Frisch had a good point that how could that not be the theory, or at least a theory, since, that's what's in all the textbooks. So and it's extremely useful. But, there is a different concept of theory where a theory by definition couldn't be inconsistent, or at least it couldn't be knowingly inconsistent. If you knew it was inconsistent, you'd immediately stop calling it a theory, perhaps. But yeah, I think it's not clear. This is one place where intuitions come apart a little bit.
So the fact that a theory is consistent, does this also mean that it is predictable, that we can, based on the theory we have, if it is really a theory, that we can predict the outcome of what the theory proposes?
In the case where it is consistent, you mean?
Yes.
Yeah, well, not always. I mean, a theory could be consistent, but very hard to implement. I mean, even quantum mechanics, you can only apply it rigorously to a very small class of systems or cases. As soon as the application becomes remotely sort of realistic, you get past the most simple cases and start trying to apply quantum mechanics to more complex systems. You can't do it rigorously. I mean, there's nothing inconsistent about quantum mechanics, or at least, there's consistent ways to interpret it. Mm-hmm. But there's nothing inconsistent about the mathematics. It's not like you can derive a contradiction, but sometimes you can't work out what it says, because the mathematics so quickly becomes intractable. So I think there's nothing to stop a consistent theory being a theory which you can't get results out of, without making major simplifications and so sort of damaging the theory from the start. And there's also cases where I think an inconsistent theory is a theory that which you can get results out of, and classical electrodynamics would be the obvious case, I think.
Mm-hmm. And since you've mentioned quantum mechanics, I know one of your areas of research is exploring the question about whether it is possible to be a scientific realist about quantum mechanics. Could you give us a definition of what scientific realism is and how this can be applied in quantum mechanics?
Yeah, sure. So the scientific realist is most concerned with the claim that sometimes we know that we've reached the truth, and we can say that some scientific theory is either true or at least approximately true. You know, typically that's said because the theory is so successful in so many ways that the realist claims it would be some kind of bizarre miracle for a theory to be that successful in that many ways and not be at least approximately true. So now quantum mechanics is a classic case where we have a theory which seems to have clearly crossed the threshold of success for the realist. You know, it's been incredibly successful and in a large number of ways. You know, it doesn't give you the wrong predictions for any experiment that's ever been done. I think I'm right in saying, you know, and that's a lot of experiments by a lot of different teams over a very long period of time. So to the level of success seems to be such that the realist has to say that it must be true or approximately true. But the tricky thing about quantum mechanics is it's unclear what it even means to say that the theory is true, because there are different ways to interpret what the theory says. So in this case, it's quite unlike a lot of other areas of science where you know what the theory is saying. You know, think of the theory of evolution. You know, you can very quickly get a good grasp of what the theory is saying about the history of life on Earth. And similarly for theories in chemistry, you know, they don't have these sorts of conceptual problems, but with quantum mechanics, the different interpretations are radically different. They say radically different things about the universe. So the realist can reach this claim that the theory is true, or at least approximately true, but is left with quite a gap where the realist has to articulate what that means, and in order to put any substance to bring any substance to that claim that the theory is true. And the realist can't choose one of the interpretations over the others because they're all equally successful as far as the empirical results go, and the realist is primarily interested in the empirical results. The realist says that's where the main evidence for a scientific theory is. It's in the empirical predictions which can be tested, or explanations of phenomena. So the realist doesn't say that we should be convinced by non-empirical on non-empirical grounds, not usually. So I don't think the realist can make a choice between the different interpretations. The realist has to stay neutral on the different interpretations of quantum mechanics. And if you stay neutral on the different interpretations, then actually what you're left with is not very much. You know, in terms of physical claims that you can make about the universe, you're obviously left with some, you know, the bare bones mathematical structure, but you can't say much about what the universe is like. You can make suggestions about what it might be like. You know, it might be like a splitting universe, sort of Everett interpretation, or it might be like the deterministic trajectories of the Bohmian interpretation, or one of the others. But I don't think the realist can say much beyond the claim that quantum mechanics is getting the structure of the world right, as unsatisfying as that is.
And is your theory eliminativism related to this? Or can it be applied to what you just said about scientific realism in quantum mechanics?
I guess it is related. I mean, part of the point of the theory of eliminativism is to avoid miscommunication. And I think that happens in quantum mechanics because people can use the word theory, or indeed the term quantum mechanics, to mean different things. So the most obvious one is people will use the word quantum mechanics sometimes to mean just the bare bones mathematics that you can just do number crunching with to get results out without even thinking about the physical interpretation. But other people will want to use the word quantum mechanics to refer to something more than just the mathematics. They want to try and refer to maybe certain claims. Maybe typically scientists go up with a collapse interpretation in mind. That's often how quantum mechanics is taught. So then by the theory, you might be thinking about, superposition states, measurements which bring about a collapse of the wave packet, and that kind of thing. So by the theory, perhaps that sort of scientist who's been brought up that way would want to include all of that. So it's I don't think there is one right way to use the term quantum mechanics, but so sometimes if you want to be really clear what you mean, you should just say, you can either use the term quantum mechanics, but then say how you're using it and what you're referring to when you use it. Or you could actually leave the term out. This is where theory limitalism comes in. The idea that there is no one theory that we all need to learn, but rather there are different legitimate ways to think about the different equations, the different propositions, the different physical claims, and the different interpretations that all sort of come under the umbrella of quantum mechanics.
Mm-hmm. So coming from a philosophical perspective in science, how do you personally view the relationship between philosophy and science? I want to refer specifically to a claim you have on your personal website that if we have a philosophical view that dictates that science should be done rather differently than how it is done, then that view is probably wrong. My understanding of this claim is that science can override philosophy, or if science and philosophy disagree with each other on a certain area or a certain topic, then it is science which is probably right.
Yeah, that is basically what I think. So let me give you two reasons for that. I mean, one is the claim that even realists and anti-realists will agree that science has made huge progress. Just think about the last 300 years or something. And in many cases, we've gone from things which were speculative theories or just ideas to claims that the scientific community and most people not in the scientific community believe to be true. Continental drift, plate tectonic, something like that. We had all sorts of theories about the Earth, but eventually, scientists hit upon the truth. There really has been continental drift. Plate tectonics is a real thing, and similarly with lots of other examples, I would include the theory of evolution. But that's controversial for some people. But there were more obvious examples. Just our understanding of various important molecules in organisms, like sugars, fats, proteins, and so on. We know what these molecules are and how they work, and so on. I mean, the progress that science has made is phenomenal. And I think compared with the progress that philosophy has made, there's not so many examples you can give where philosophers used to be all debating different ideas about X, but now we've reached a case where we know the answer to X. I don't think philosophers can say that in the same way that scientists can say that about certain different X's. So there's an important difference when it comes to progress between science as a discipline and philosophy as a discipline, I believe. The other consideration is evidence. Typically, the evidence for scientific claims is stronger than the evidence for philosophical claims. typically the evidence for any philosophical claim is an argument, and it's not like philosophical claims are tested by the predictions that you can get out of them that can be then subjected to experimental test. And that's a really important type of evidence. It's the most important type of evidence for scientific claims, and philosophy doesn't have that, or rather, any philosophical claims which can be tested empirically, really become scientific claims by virtue of the fact that they can be tested empirically.
Moving on, I would like to briefly discuss with you a question in philosophy which even people who don't study philosophy or do not know much about philosophy have come across, and it relates to your research, and more specifically, you have done a talk based on this question, specifically on the question: if a tree falls in the forest and there is no one around to hear it, does it make a sound?
Yep.
Now, I'll provide my own perspective to the question, but first I would like to hear your reply to this question.
Yeah, so on the face of it, we have a choice between two possibilities. The tree really produces sound, and the sound travels through the wood, and there's no one there to hear it, but nevertheless the sound travels through the wood and sort of dissipates and is gone. And yeah, if somebody had been there, they would have heard it, but they weren't. So that's a common sense view, and I think that's a view that we sort of grow up with. There's an alternative. The alternative seems to be that, I mean, the tree falling over sets up a compression wave in all the particles in the air, and there's nothing soundy about that compression wave. It is just particles bumping into each other in a certain pattern. You know, they get close together, further apart, close together, further apart, and that's just what I mean by a compression wave. I mean, and to call that pattern of particles moving sound, I think, is misleading, because we often reserve the word sound conceptually for our experience of sound. You know, the ting of a triangle when you strike it, or the sound a trumpet makes. You know, and when you say the sound a trumpet makes, nobody's thinking about particles bumping into each other in a pattern. You know, rather we're thinking about that characteristic sound that a trumpet makes. So the alternative view is that there is no sound traveling through the wood, but rather there is only this compression wave. And were somebody there in the wood, that wave, that pattern of particles would go into their ear and would be turned into an electrical signal which travels up the auditory nerve. That electrical signal itself not being sound, but rather just, it has just electrical properties. And then when it reaches the brain transforms that information into a sound experience for the hearer. Mm-hmm. So they're the two alternatives. My view is that there is the evidence is much stronger for the view where it's just a compression wave going through the wood, and sound as experienced is not going through the wood. So the answer to the question would be no. The tree doesn't make a sound.
I tend to agree with you. I see like someone who answers yes to the question. I think they view the issue in a very much anthropocentric way. We might say that it's true that the tree produces compression waves or sound waves, as we call them, but it is true that the experience of sound, the sound as qualia, is only present because we as humans transform those compression waves into the experience of sound. I mean, it would be possible, I think, if for another being if those compression waves triggered some optic nerves in their brain, and they would see images through those compression waves.
Hmm.
So it's not necessary, I think, for those compression waves to produce the experience of sound. I don't think anyone denies that the tree produces those waves, but and perhaps this is a different understanding of the term sound. Physicists might use sound to also mean the waves, but if we just talk about the experience, then it would be too anthropocentric, I think, to answer a definite yes to the question.
Yeah, I think we have to accept that the word sound is used to refer just to those waves very often. I mean, if you just Google what is the speed of sound, then you get lots of information about that, and it's all about those waves. So those waves are being called sound, and some of the articles you find are written by scientists. I think most scientists are on board with this idea that the compression wave isn't itself sound, but is rather just particles moving in a pattern. So, but since scientists, talk about the speed of sound, then they are using the word sound to refer to those waves. And you could just take that attitude and say, look, the word sound is ambiguous. It's used to refer to the waves, but it's also used to refer to our experience when our brain processes that information. But yeah, I think there's a lot of misunderstanding because of that ambiguity, and the way that kids the world over are educated, and including me, that sound is a vibration in the air. And one of the things that really made me more passionate about this issue was that I looked at some past GCSE exam questions which 16-year-olds in the UK take, and you can find the questions online about sound, and nothing in those questions requires you to recognize that there is this issue about whether the compression wave really is sound or if it's just particles moving. So somebody who thought the compression wave itself is sound moving in the air, for example, you might think that it's the metaphysical grounding of sound or something like that. Such a person would get full marks on those GCSE questions, because they just leave it open, which way is the right way to think. So I do think there's a lot of misunderstanding out there, because of the this issue of how the word sound is used, and yeah, I think it's a big issue because I think the difference is really significant for our understanding of how we interact with the universe around us as human beings, and how our brains distort, if you like, the world to give us a vision of the world, and what is happening in it. So I think that's something that's missed in education systems across the world, which just don't bother to address this question. If a tree falls in a wood and no one's there to hear it, doesn't make a sound. That question is not being asked, I believe, in any education system in the world, but rather the education systems want you to be able to get comfortable with talking about peaks and troughs in a sound wave, or the amplitude. They want you to get comfortable with key concepts like, if you like, pitch, frequency, and wavelength. So the questions sort of test knowledge of those concepts, but they don't test this grander question of whether the compression wave really is sound or not.
So I guess the more general question on this topic would be, can something exist without it being perceived by consciousness? We have talked about sound so far, but do you think we can extend the same way of thinking to images or to vision? Like if there is no conscious mind to see something or to perceive something, does it still exist? Do you think that the question only applies to sound, or can it be extended to other senses as well? And if I remember correctly from your talk, you also talked about light and light in a dark room. If you could remind me of your argument exactly.
Sure, yeah. I mean, the classic case the classic case concerns colors.
Mhm.
And this is a classic debate in the history of philosophy and science. The this distinction between primary and secondary qualities, um, and colours were very early on. The main focus, is the strawberry really red, or is that just the way that my mind represents it as being? But I think there's a bigger issue, which is light itself. I mean, suppose you accept that the case of colors is like the case of sound, and you think that those colors are not really there in the external world, but are qualia, as you said, just a way that our mind represents the world, or different properties in the world, but not color properties. Um, well, you might reach the conclusion then that the world is black and white, but it seems to me that you could make the same case really for black and white. It's not like white in particular. We get a sensation of white when light is entering our eyes, and you could ask, well, is the electromagnetic radiation entering our eyes really white? And I think if you follow this line, you have to say no. You have to say, well, no, it just has electric and magnetic properties, and other sort of physical properties like wavelength and so on, but it's not really white. So then you seem to reach a conclusion that the universe is dark or black, perhaps. But it's unclear. I haven't been able to find any discussion of how we should think about black. Black's typically a color. I mean, if you look at a piece of black paper, you might think, well, why do you get a sensation of black? Is it because there's electromagnetic radiation of a certain wavelength? You might think, well, no, you get a sensation of black when there aren't any wavelengths that we human beings are able to interpret. So I have to still decide what I think about this case, and the potential conclusion that the world itself is not lit up, but it's just full of electromagnetic radiation, and we see it as lit up. So our experience of a lit up world is at odds with how the world really is. This would be the ultimate conclusion, the claim that light is not really out there as such. Electromagnetic radiation is, of course, of all different wavelengths and frequencies and so on, but that doesn't mean that the world is actually lit up. That would be a more disturbing conclusion, really, as it's the idea that the universe is just a place of pitch black darkness, and we sort of bring with our concepts and our experiences, we sort of bring the light to it, if you like. We interpret it in a certain way, and we tend to assume that's the way it is in itself. If we were to all die out, the sun would still shine, but it seems that the shininess of the sun is a secondary quality. It's not a physical property of the electromagnetic radiation that the sun is emitting. So would the sun still shine? Well, we don't have to die out, even without us dying out as human beings. I think on this line of thinking, you reach the conclusion that the sun is not shining even now. That's just the way we interpret it.
I am,
What do you think? Are you convinced?
yeah, I tend to agree with you that all we see is how we interpret it, and we interpret it in this way because of how we, as humans, function. That we uh, we see the sun as a distinct object which emits light, and we see light in a specific way, but another being could see light in a totally different way or experience heat in a totally different way. I don't see the way we experience heat. I mean, the experience of heat and heat as qualia, that it necessarily has to be what we as humans experience.
Yeah, I think that's right. I think this there are different ways to be successful as an organism, and I mean, one thing is you don't want to be eaten by other organisms, and that sometimes means you have to have some kind of signal that there's an organism behind you. But that signal doesn't have to be a hearing sensation, right? Any kind of sensation would be useful from an evolutionary perspective. So as long as you get some signal that there's something behind you, then that would be fine. So obviously hearing is very useful to us, and there are a great many human beings who, if they couldn't hear, would have died a long time before they did, and wouldn't have been successful, wouldn't have passed on their genes, and so on. So hearing is really useful, but there are other possible experiences, qualia, that perhaps we can't even conceptualize, that just some kind of experience that tells you there's something behind you and it's time to run. That's all you need. So I don't think it's necessarily the case that the hearing experience is essential for any successful organism.
I'm thinking bats which use sonar, for example, or bees who guide themselves with the magnetic field of the earth, like senses that we do not have as humans.
Yeah, that's right. There's some good examples actually already on our planet. Never mind moving to other possible alien species on other planets. So yeah, there's I mean, yeah, bats are a good example of how you can see using in a different kind of physical means. In that case, they're obviously listening to the echoes from the waves that they cast out. I mean, it could still be the case there that, I mean, the reason they're doing that is so that they can navigate the world around them, and they do that incredibly successfully. But yeah, we can't be totally sure. Or some people would say we can't have any idea what their experiences are like. But on the other hand, there has to be something, at least an analogous, I would say, to what we experience. Because yeah, they have to have some concept, for example, of, this structure is closer to me than that structure, and that one is further away than this one, and so on. So whether you could call that sight, well,
Yes.
I'm not sure.
Yeah, we might call that sight, or we might say that bots see or perceive something, but that's totally different from what we mean when we say that humans see. It's not visual, it's something else, but we can still say that bots see because, as you said, they understand distance, they understand maybe the size of objects, and that's what we understand as well when we see something?
Yeah, I I actually don't know of a great deal of good recent literature on these issues. So I need to investigate that now. I haven't found any discussion, for example, at all of the idea that you know light, the shininess or brightness of light is just all in our heads, and the universe might be best described as a place of darkness. I've never come across that before, so I imagine it's out there somewhere, but I'm yet to find the literature on that idea.
Hmm. Hmm. And taking everything we've discussed and coming to my final question, uh, would you say that science is misunderstood in philosophy? And how do you think that philosophy can change to better understand and adapt to science?
Yeah, I think so. There was this debate in the 20th century with Quine and others about naturalizing epistemology. So this is a pretty famous debate um, where, as I recall, Quine was trying to say that we should take a more scientific approach to epistemology. But I think this idea was defeated because on the grounds that there are philosophical questions and there are scientific questions, and sometimes the scientific questions are not the ones you want to ask, and the scientific methods are not the ones that are going to help you answer your philosophical questions. So it's not as if there was a revolution where everyone realized, oh, we need to do epistemology differently. We need to do it in a more scientific way. I think that there have always been calls for making philosophy, if you like, more scientific, more rigorous. I think this is what the logical positivism and that sort of movement was about, verificationism, in sort of the 1930s and 40s and so on, Carnap and others. I agree that there are quintessentially philosophical questions. I mean, there are always going to be people who think those questions are either empty or there's no way we can ever answer them. I don't agree with that. I think there are perfectly legitimate philosophical questions which science doesn't have a bearing on. And we should investigate them using quintessentially philosophical means. The classic approaches to answering philosophical questions. What I think is sometimes missing is are the cases where I think scientific knowledge can inform philosophical debates. I think that's clear. At least sometimes that can be the case. I also think it's possible for a philosophical debate to go on and on for a very long time without that scientific knowledge actually informing the debate. So that's the kind of case that I worry about. I mean, the philosophers in that debate may not have that scientific knowledge or know about it, or they may not realize that it is scientific knowledge. They might think it's just scientific speculation. I mean, sometimes it's hard to see what we should count as scientific knowledge or a fact and what is just a theory, which you can perhaps ignore for now because it's just speculation for now, at least. But there are at least some cases, I think, where the philosophical debate can go on, perhaps when it ought to be informed by certain scientific results. So, yes, I mean, scientists and philosophers don't talk to each other that often. And a lot of philosophers were not trained in science at all. Even the ones that were, gave it up at A level. So they may well not not realized that there have been these or that developments, or so it's tricky. I mean, to give one example, there are at least some debates in the philosophy of time which could have been moved on far better, I think, far earlier, if all the protagonists in that debate had a thorough knowledge of special and general relativity.
Mm-hmm.
So that could be one example, I think.
That's true, I agree. So, Dr. Vickers, thank you very much for your participation in the podcast.
Thanks. Yeah, it was fun. Thank you.
Thank you very much.
You have just listened to Premise Podcast. Subscribe to Premise Podcast on YouTube and make sure to follow the podcast on Twitter and Facebook. The podcast is also available on Google Podcasts, Apple Podcasts, Soundcloud, Stitcher, and Spotify. Please consider supporting Premise Podcast on Patreon to help bring philosophy to the public. See you next week. Thanks for listening.